Okay, next lecture. It's the lecture I2, Interface, Facade and Services. This lecture deals with the interaction between the building envelope, the facade, and the services being integrated to explain service types of interfaces and the opportunities for integral product development. We're going to show some samples. And what you see here in this picture is there's a facade in the north part, and then you see the first components being in a more, say, craftsman-like way integrated into this facade. We're going to talk about that later in this lecture. The relevance of this, the interaction between the building envelope and the building services obviously determines extremely the energy and comfort performance of the building. It's part of the value of the building, 30 to 50%, half of the building costs next to structure and interiors to be taken into account. And the efficient interaction between them from engineering through operation is key to achieve a low energy built environment. So well-performing buildings, and by that low energy built environment. What are building services? Building services do refer to technical systems responsible for the safe, comfortable, and environmentally friendly operation of a building. They include MEP, mechanical, electrical, plumbing, or public health services. This is mainly water, electricity, gas, mobility, elevators, escalators, and eventually waste and grey water. And as a separate part of, or an inner part of that one, HVAC, health, ventilation, and air conditioning are part of the MEP. And this is to manage the user comfort such as temperature, light, air quality, and humidity in the building. This is what MEP and HVAC do for our buildings. So how is this related to our buildings? Now, obviously, light, sun protection, ventilation, heating, but also cooling, as it is defined here, is part of this interaction, which we need to define with the building envelope. There are some basic functions where traditional facades are performing. It's structure, illumination, heat, noise protection, humidity control, fire protection, over voltage protection, fresh air, glare, and visual communication. So our opportunity to watch through the facade to the outside environment, which is a relation which we always want. We have energy-related functions such as solar, thermal, photovoltaic, if requested energy storage, heat exchange, maybe even phase change material as a kind of heat exchange within these systems, which could be used. And then there are some supply functions, so service functions, which a building envelope can take in the means of MEP, mechanical ventilation, heating, cooling, humidity, dehumidification, electricity, artificial light, information and communication technologies if requested and implemented into this facade design. And then there are additional functions which we can envision. LED, media protection, the media facade, one type of green facade, the passive air purification system, so getting humidity control. And another aspect of green facades, if we are interested in that one, food production, which means food, or algae production, which means algae is to be fired then, and a kind of an energy production, monitoring systems, and adaptive facades if this is designed like, for example, a variable U value. That would be something really interesting to get this in a mainstream type of facades edited. How facades and services have an interface. Facades and services are closely related in a number of ways, such as aesthetics. So we need to design this part, very nicely designed services integrated. This part, a facade where later the user needed a certain services and integrated it into this window. And we see the result. And we may think about this in an aesthetical manner. So the integration is needed for aesthetical reasons. And we also have to think about centralized versus decentralized systems. Centralized building services rely on large equipment, which then supplies the entire comfort for the building. And we see all these pipes going up into ducts at the top. And then there's the huge device which does all the ventilation for the building. It's either on the top or in the basement of a building, and supplies fresh air, for example, for the building through the ducts. versus a decentralized service system. When we see the facade at that side, we see the heating cooling device, then heat exchange, and then it goes into the used areas. As a decentralized system, these decentralized systems do reduce the numbers of ducts. Obviously, it also reduces the numbers, the dimension of the individualized components, but it also delivers the consequence of a fragmented HVAC or MEP system being integrated. This one is for ventilation as well. So the pros and cons. Pro for an centralized system, it's concentrated technical equipment, which also means concentrated maintenance. The con is obviously it needs to be central controlled, and the central control means also central conditioning, versus the decentralized version, which is an independent operation. You can operate the service when needed. You condition only that part, and also and the cons are obviously as well. It's a fragmented technical equipment, and also fragmented maintenance, which is then the question which you need to discuss as an opportunity. The collaborative performance is something which you can say imagine, where the centralized or decentralized the building envelope and surfaces must be engineered to work in parallel. The one thing won't work without the other thing. The U value influences the need of heating and cooling of the building. The G value, the amount of light getting into our building, obviously also determines the dimension you need for your heating and cooling system within a building. Orientation, dimension of openings, this all defines very much how much energy you lose with the building, how much energy you gain with the building, so how much energy you need to deal with the building to create a comfortable indoor climate, as named. And as said, this covers 30 to 50% in new construction building envelopes, as we see here. Building envelope services are about 30, 40, maybe 50% if it is new construction. And if it is an existing construction, which is going to be refurbished, a heating system, building envelope system, ventilation, because structure is already built, it's even more. It may end up in 90, 95%, as these numbers say, being related to the renovation of these services. Construction operation, efficient interaction between them can lead to optimized equipment dimensioning, sure. So if we say define very wisely the G and the U value for our facade, we may reduce the need of heating or cooling for our systems, and it lowers the costs of construction, obviously, and by that also for the operation. How is this done? There's a number of integrated services designed, several projects which were started somewhere in the 2000 to 2010 period. A lot of activity happened in that environment, but still, say, serious implementation in a larger scale is kind of missing, which is an interesting experience. So the conclusion of this: facades and building service together mainly determine the indoor comfort and energy performance of a building. Obvious. Since this may, to their functional performance, overlap in facade, integrated building services are a promising alternative to centralized centralized services. So you actually have them decentralized, place them in the facade, you have them accessible with the facade. It's actually a similar industry, but it's on the other side a fragmented situation. As we say in bullet point 3, have the advantage of being decentralized, but in the decentralized situation being fragmented, and by that have the disadvantage of additional say needs of maintenance. Facades and building services represent a large fraction of the project's cost, particularly in renovation. Yeah, as said, 50%, maybe 90% as a project. And by this, I stop this lecture. Hope you enjoyed it, and we can continue with lecture IO3. Literature, the people participating in the Delft Darmstadt meeting project. And here I end this lecture.